are going to be starting our probability unit. This is a week-long unit, so we'll be done with this on Friday. But we're going to start by starting on scatter plot. So what is a scatter plot? A scatter plot is a graph that shows the relationship between two sets of data. So that is what a scatter plot is doing. It's showing the relationship between two different things. So showing them how do they relate. When we talk about these relations, we have three types of relationships. So if I were to draw a graph here, I'm going to draw one so it's just pretty much showing quadrant 1. I'm going to have three different types of relationships. We did talk about these last year a little bit when we were in 7th grade, so this might be a little bit of a refresher for some of us. Some of us, we might need more of a refresher. So a positive relationship is dots that are pretty close together that are forming a line that's going in the positive up direction. Negative then is the opposite. It's dots that are pretty close together, but this time they are going down, so they are going in the negative direction. So positive relationship, negative relationship. None, this is what I call the chicken pox graph because it's just a bunch of points that are graphed, and your graph looks like it has the chicken pox. Okay. So we can call this, if we want to go along with the chicken pox, this could be a rash that's going up and then a rash that's going down. I don't know. I'm trying to help you guys remember them. So, anyways, moving on. To determine the types of relationship most likely shown by the data. So these three are going to represent one of these, and we need to determine which one we think it would be. So the size of a home versus the size of its lot. Which one of these would that have, do you think? So the size of the home, like how big our house is compared to how much land it's on. Does that have a positive relationship, negative relationship, or none? None. There's no relationship. I could have a really big house, but not a lot of land. I could have a really small house and have a lot of land. I could have a lot of land and have a big house. There's no relationship by how big your house is and how much land you have. Okay? How about the number of passengers on a plane versus the number of suitcases that's also on that plane? So if I have more people on my plane, am I going to have more suitcases or less? The more the people. We're saying how do they relate to each other. Yep. So the more people there are, the more suitcases there's going to be. So that's going to be a positive. Now number 3, the number of days into fall versus the number of leaves on the trees. Negative. Because the farther into fall we get, the more leaves that are going to fall off our trees. So there are a few examples of our types of relationship. So what we're going to do now is we are going to graph some of these relationships. So we're going to graph this scatter plot first. You're always going to have X in your first column and Y in our second column. X is our sideways, our horizontal line. Y is our vertical, straight up and down. So I'm going to have hours on the bottom while I have grades on the side. What I'm going to do here is I have to figure out what would make the most sense to label our graphs. Well, for x, I have the lowest number of 1 and the highest number of 8. What makes the most sense to count by? 1. So I'm going to go 1 hour, 2, 3, 4, 5, 6, 7, 8. And you can keep going until you get to 10, or you can just stop at 8. Grades. My highest is 100% and my lowest is 45. So what do you think would make the most sense to count by? Tens. Very good. So I'm going to have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Another thought that would come into mind for me is counting by fives. However, if we count by fives, we're going to run out of room on this side. So we have to think about what's the most logical to count by and how much room do I have to count by as well. So now all we're going to do, we know how to graph points, so we're going to graph those points. So I go to the 3 hours on the x, and then I go up to 80. There's my first point. 5, 90. 2, 45. So since this is 45, I go in between the 40 and 50, halfway, because that's 5. So this would be 45 right here on my graph, in between those 2 points. Then I have 685, so same thing, go right in between that 80 and 90. So that's how you get 85. 895. 155. 260. 700 and 475. So this scatter plot here is representing the relationship between how many hours they study, our students study, comparing that to the grade that they got. What kind of relationship can we conclude that the hours we study and our grades have? Positive. So this means the more hours I study, the better the grade. So the more hours studied, the better the grade. So what we're going to do is we're going to do that same exact thing, but with the number of hours a person spent in the mall and the amount of money they spent. Okay, so I'm going to go ahead. X is hours, Y is dollars. So I'm going to have my hours on the bottom, and I'm going to have my dollars on the side. What does it make most sense? So 1 is my lowest hour, while 9 is my highest. What should we count by? Ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I have my lowest number as, what do I have? 25? And my highest is 115. What should we count by? The lowest is, yes, it is 15. Tens. I'm going to count by tens, but I'm going to show you guys a different way of how to do that. This gets really crammed right here. So what I'm going to do is I'm going to count by every other. So this one's still 10, but instead of writing 30, or instead of writing 20, I'm just going to skip ahead and go to 30, but I'm just not going to write anything at this line here. That's just so we can read it better. You can definitely go ahead and write 10, 20, 30, 40, 50, whatever you would like. But just so we have enough room and it looks a little bit nicer, I'm going to do every other. And then I am going to write this 120 on the top one, just because it's my last one. Okay, then we're going to go ahead and we are going to graph them. So for 1 hour, they spent $40. 8 hours, spent 25. So that's halfway in between the 20 that we don't have written down in the 30. 730. 570. 240. For 3 and 115, 115 is going to be in between that 110 and 120. And then 15 is between 10 and 20. Do you guys have any questions on the dots that we graphed? Okay, looking at this graph here, what kind of relationship does the number of hours I spend at the mall have to do with the number of money or the amount of money I spend? No. None. There is no correlation. There is none. So what this means is the number of hours spent at the mall has no relationship with the amount of money spent. Okay. So now what we're going to do we have any questions on this front side here? Okay, flip to the back side then. And now what we're going to do is we're going to look at examples that have to do with years now. So the percent of households in a city with a landline telephone. So X is going to represent my years and Y is going to represent the percent. So years is going to be on the bottom here. And then percent with landline. So I'm going to write that as percent with landline. So I didn't actually write out the word percent, I just wrote the percent symbol. When we are working with years, what we are doing is I'm going to count the y-axis right here. This is going to be year 2000. Okay? And yeah, that's what I'm going to do. I'm going to actually turn my paper sideways to help me better write my years out. I'm going to then count by every 2 years. So this is going to be 02. This one's going to be 04, 05, 06, 07, 08. Wait, do I want to count by twos herb ones. Yeah, we probably should count by twos because we have to go all the way up to 18, don't we? Oh, everything is in twos. Hey, good observation. Everything's in twos, so let's count by twos. So, let me find my whiteout. If I have any left. Okay, I don't have any left. So, let's just count by twos. So, this is going to be 02 still, but then 02 would be right there. So then this one would be 04. So then when we have 06 technically, 08, 2010, 12, 14, 16, 18. Okay, hopefully your graph looks better than mine does. On the side here then, so we have the lowest as 42% and the highest at 84%. What do we want to count by there? I'm probably going to count by the 10. We can do 10s again. But I'm going to just do every other. So 20%, 30%, 40%, 50%, 60%, 70%, 80%, 90%, and then 100%. So I'm going to count by 10s on this side, but I'm just going to plot down my even ones this time. So in 2000, that's where I'm going to have it right on the line for 2000. 2000 is at 84%. So I'm going to go to 80, and then I'm just going to go a little bit above, not halfway, but almost halfway. Then for 2002, I have 80%. So 2002 is now at 80%. 2004 is at 73. So again, just a little bit above that 70. 2006 is at 68. 2008 is at 65. 2010 is at 55. 2012 is at 51. 14 is at 47. And then 16 is at 42. Well, yes, this is a scatter plot, but this creates a pretty straight line. So what kind of relationship does, as the years went on, have with the percent of people with landlines? This is negative. How do we feel about years and graphing years? Good. I'm going to talk about number 7, just the graphing, like the line part. So my lowest year is 2009, and it goes up to 2017. So what I'm going to do is I'm going to count the years by 1. I'm going to have this first one right here be 2009 right on my line here. So my first line is going to be 2010. Then I'm going to have 11. Then I'll have 12. I'm going to write down every other just so it doesn't get crowded. And then, so 13, 14, 15, 16, 17, 18, 19, and then 20. So that's just if you need to have another reference of how you would graph the year, that's another reference there. Okay, any questions about how to graph our scatter plots and how we find their relation and which one represents which? All good? Okay, then we're going to talk about reading scatter plots. So how do we read and understand scatter plots? So it says, it says a company's stock price since it launched in 2006 is shown below. What is the approximate stock price in 2015? What? So 2015 would be right here. So that gets me to this dot right here. And it's slightly above the 20, not quite halfway yet. So I would estimate that to be 22-ish. If you said 21, 23, that's fine. I just wouldn't say 25 yet because it's not quite halfway there. So, and this is approximate, so that means close to my answer. Now it's asking me to answer, in what year or years was the stock price $35 per share? So I'm going to go over here because this is dollars per share. I'm going to go to $35. This is counting by fives, so 35 would be right here. I want to know what years, so if there's any dot on here, that would land me on it. So what years, there's two dots. Which years are those? 2010 and 2012. And what kind of relationship did this company have with their stocks? So the stock price dropped every year, so that would be negative. On my next one here, it says Olivia bought a used car in April. The graph below shows the odometer reading each month after she bought the car. So how many miles it is on the car. So approximately how many miles were on the car when she bought it? So when she bought it, that would be month 0. That would be our line right here. So how many miles can we approximately say were on her car? And it looks like we're counting by twos. Because it goes 2, 4, 6, 8, 10, 12. So that looks like it's pretty exactly in between the 2 and the 4. So what's exactly in between 2 and 4? 3. But this is in thousands of miles, remember? So this would be approximately when she bought the car, there'd be roughly 3,000 miles on it. What about approximately how many miles were on the car in July? Well, this is in number of months. If she bought the car in April, how many months have passed? April, May, June, July is how many months? 4 months. So I want to look at month 4. So I go to month 4, and how many miles are on there? So 8,000. Okay. Now I want to know, in what month did the car reach 14,000 miles? So I'm going to go to my 14, which is right here. And which month is that? That's month. What month is that? It'd be month 9, which is which month? So go start at April and count how many months is that away. Well, April, May, June, July, August, September, October, November, December. I'm waiting for somebody to say the answer. January. So 9 months from April was January. Okay, because remember it says in April, that's when she bought the car. Okay, do we have any questions on how to read a scatter plot, how to graph one, anything like that? Okay, now we're going to talk about lines of best fit, which this part's going to be really easy to you guys because you are very used to finding lines and graphing lines and everything like that. So on the next page here, it says lines of best fit. So what is a line of best fit? Well, this is a line drawn on a scatter plot that is close to most of the data points. This can be used for estimating. Okay, so what we're going to be doing is we're going to be graphing lines. So everything's going to be graphed for us. We're going to be graphing lines that, and we were going to see which ones overlap the most dots. So on number 1 here, I have y equals 2/3 x plus 50. Remember, our lines are y equals mx plus b, where m is our slope that tells us how we move, and b is where we begin. That's our y-intercept. Okay, so the graph below shows the relationship between minutes spent studying and the test score for a math class. Which line best represents the data? So it says graph each line to justify your answer. So on line A, I'm going to start at 50. Well, that's right there. From there, I'm going to go up 2 over 3. So up 1, 2, over 1, 2, 3. Up 1, 2, over 1, 2, 3. And then what I'm going to do, once you guys all have your own ruler, I'm going to connect those dots that I connected. And I'm going to graph that. I'm going to connect them. Darren, will you hand one out to everybody, please? Okay, so that was line A. Now I'm going to graph line B. So again, I start at 50. However, this time I'm going to go up 3. 1, 2, 3, over 2. 1, 2. Up 3. 1, 2, 3, over 2. I have 3 dots now that I'm able to connect with a ruler and trace. Okay, there's line B. Line C then, what I'm going to do is I am going to start at 55. So I'm going to start up, and our graph is counting by 5s. And I'm going to go up to 1, 2, over 3. 1, 2, 3. I'm going to go up to 1, 2, over 1, 2, 3. Okay, well those ones both landed on points that I had graphed already. I'm going to line them up. And I'm going to connect the dots. And then I'm going to graph the last one, which is line D. So I'm going to start at that 55 point again. But now this time I'm going to go up 3. So 1, 2, 3 over 2. 1, 2. 1, 2, 3 over 1, 2. Then I'm going to take those points, connect them right there, and that would be my line D. So as we're looking at these, what I want to see, which line overlaps the most points? Line C. Line C landed on actually 2 of our points. So our line of best fit would be y equals 2/3 x plus 55, because it overlaps the most points. So what we could do with this line is, if they were to say they studied 120 minutes, we would see this line, we just extend it to 120 and see where it would best be at. Or I can just plug in 120 there and graph that. Carol, will you answer the phone, please, and say it's my room? Now what we're going to do is we are going to take these and we're going to draw a line that is close to most data points. It should split the data. Then what we're going to do is we're going to find the slope between any 2 points on the line. We're going to have to use our slope formula. What is our slope formula? Who remembers it? That's point slope form. So it's m equals, we have 2 points. So we're going to have y2 minus y1 over x2 minus x1. Okay? Then you're going to identify the y-intercept, the point where the line intersects the y-axis, and you're going to write an equation in that y equals mx plus b form. Okay? So what we're going to do is we're going to take this, and then we're going to look at our points here. Okay? So our first thing is to draw a line that most fits the data. Okay? So what I'm going to do is I'm going to take my ruler. I'm going to line it up with that y-intercept. I'm going to angle my ruler and see where it hits the most dots. I'm going to say that's going to be right about here. So we want it to be in the most middle point. Okay, then I'm going to take my pencil and I'm going to draw a line. What I'm going to do now is I'm going to need to figure out what my M is and what my B is. Well, my B is easy to find. What is my B? Where do I intersect the y-axis at? What's this point right here? What's my y value? So let's see, we're counting up by, so we have 4, 10, 16. So I'd say 4, this would be 8. What are we counting by? 28, 22, 5, 6, 7. Oh, we're counting by 3s. So this is going to be 7, 10, 13, 16, 19. Okay. So we're starting at 3. So what's my y-intercept? What's this point it's starting at? What's that value? 7. Thank you. Okay. Now what I'm going to do, how do I find my slope? Make sure we're paying attention because I have some people who are not. Okay. My formulas, m equals y2 minus y1 over x2 minus x1. This is where your answers are going to vary. Because I am picking 2 points on my line. Well, depending on how we drew our lines, we're going to get different points. I'm always going to choose the y-intercept because that should be the same point at least for everybody. So I'm going to choose the point 0.7. But if I look at my line and the line I drew, my next point that would hit nicely would be 210. And now that might not be the same for everybody depending on what you angled your line at. Okay, so now what I'm going to do is I'm going to, y2 is 10, 10 minus 7 because that's y1, y2 is 2, or x2 is 2, y1, or x1 is 0. So then I have 3 over 2. So my slope is going to be 3/2. Which depending on which 2 dots you use, they might vary. So it's super important you write down these 2 points right here. Okay? So what's my equation then? Mine is y equals 3/2 x plus 7. So what's going to vary is our slope's going to vary. Our y-intercept should not vary because we all should be starting at the same point. Now what we're going to do is we're going to estimate the weight of a baby that is 12 months old. So what am I going to do then? What does x equal? What does x equal, boys? What? How old is our baby? 12 months. And this is our age in months. So I'm going to plug in x. I'm going to plug in 12 for x. So I'm going to have y equals 3/2 times 12 plus 7. So what I'm going to do is I'm going to take 3 times 12 to get 36 and divide that answer by 2 to get 18. So I have 18 plus 7. So roughly this 12-month-old baby is going to equal 25 pounds. Now this might be different. Some of you might get 26 pounds. Some of you might get 24 pounds. Some of you might get a decimal. But that's because your slope might be different than mine. That's why the answers will vary. Are we good with how to determine this line of best fit? Okay, we're done with notes for the day then.